Okay, hello everyone. Welcome to our video. This is our midterm project for a course at Fulbright University called Probability and Statistics. So today we're going to introduce you a pretty iconic problem in probability, which is called matching problem. So this problem is taken from a book called First Course in Probability. Okay, let's dive right in. So the problem is, at a party there are a total of n men, and each of them has their own hat, and they took off their hat and mixed them all up, and then each man pick a hat in all of the hats. And so the question is, what's the probability that there are no matches and the probability of exactly k matches?
So to calculate the probability of no matches occur, we let E denote the event that no matches occur, and let Pi denote the event that I matches could not occur. Therefore, we see that is actually Pn. And we start by conditioning upon the event that the first man selects his own hat or not. We let M1 denote the event that the first man selects his own hat, and let M1C denote the event that the first man does not select his own hat. So, according to the total probability rule, the probability that no matches could not occur is actually equal to the sum of the probability that no matches occur and the first man select his own hat, and the probability that no matches occur and the first man does not select his own hat. And so and apply the property of probability, we have the equation here. We could clearly see that the event that the probability of the event that no matches occur given that the first man select his own hat, which denoted by E given M1 is equal to 0. And beside, the probability that the first man does not select his own hat but select among n minus 1 hats of others is equal to n minus 1 divided by n. Therefore, we could say that the probability, the desired probability, is equal to the probability of E given M1 C times n minus 1 divided by n. Now let's look at the probability of E given M1C, which is the probability that no matches occur given that the first man does not select his own hat. So to calculate the probability of E given M1C, we continue to condition on whether or not the second man, which is the man with his hat chosen by the first man, selects the first man's hat. We denote this event by M2. So you can see from the illustration that the blue man selects the orange man's hat, and there are two cases. The first case is the orange man selects the blue man's hat, and the other case is he does not. Now let's look at the first case. So in the first case, the probability of the orange man would select the blue man has equal to 1 divided by n minus 1 because he has to choose one hat among n minus 1 has left. Given that the blue man and the orange man select the hats of each other, the probability that there are no matches among the other n minus 2 men would be denoted by P E given M1C and M2, which is P n minus 2. Therefore, the probability of case 1 would be equal to the product of the probability of the two steps. The first step is the second man choose the first man head, which is 1 divided by n minus 1. And the second step is the probability that there are no matches among n minus 2 matches left. So, in the second case, although the blue man selects the orange man's head, the orange man does not select the blue man's head, and this probability is equal to n minus 1 divided by n minus 2 divided by n minus 1, because there are still n minus 2 heads for the orange man to choose from. Given that the probability that the second man does not select the first man's head, the probability that no matches could not occur, no matches occur would be denoted by the probability of PE given M1C and M2C. And you could see that the probability of this second case would be equal to Pn minus 1, because it is very similar to the problem in the beginning, in which there are no matches given that the first man does not select his head. Therefore, we could see that these two equations is equivalent, and we could conclude that this probability is equal to Pn minus 1. To calculate the probability of E given M1C, we combine the probability of case 1 and case 2 together, because these two cases are mutually exclusive. And the probability of case 1 we have calculated is equal to 1 divided by n minus 1 times Pn minus 2. And the probability of the case 2 we have calculated is Pn minus 1. And we have also proved in the very beginning of the problem is that Pn is equal to Pe given M1C times n minus 1 divided by n. Therefore, we take this equation times n minus 1 divided by n. We have Pn is equal to this equation, and here we are presenting Pn by Pn minus 1 and Pn minus 2, and we take Pn, subtract Pn minus 1, we have this equation. However, since Pi is the probability of no matches when I man selects among their own heads, we have P1 is equal to 0 and P2 is equal to 1 divided by 2, and apply the general formula that we have proved. We have the subtraction between P3 and P2 is equal to minus 1 divided by 3 factorial, or P3 is equal to 1 divided by 2 factorial minus 1 divided by 3 factorial. And similarly, we have P4 is the following equation, and in general we could conclude that PS is equal to this equation.
Okay, let's move on to the next question. The calculating the probability of exact decay matches. So for this one, if you think about it, there are actually two independent events. The first one is that the K men select their own hat, and the second one is the rest of them, the N minus K men, do not select their own hat. So for the first one, the probability that the first man will select his hat is 1 over n, since there is only one option for him, obviously. And for the second man, that would be 1 over n minus 1. And for the third man, that is 1 over n minus 2, and so on. So for BA, we have this short formula, n minus k factorial over n factorial. Move on to the second event. Actually, that would be the probability that we have calculated in the previous part. So we just now adopt it, and that would be p n minus k. Okay, I hope that was clear for you so far. Actually, we're still missing one step here, which is choosing k men among n of them. So that would be c, k, n. And putting everything together, we have this very nice and short formula, b n minus k over k factorial. All right, that's pretty much it, I think. All right, so just to sum up, there are 3 key ideas that we want to bring to your attention. For this problem, first we need to condition upon whether the first man will select his own hat, and then we continue to condition on whether the second man will select the hat of the man that selected his hat, or he would select among n minus 2 other hats, and then create a recurrence formula representing bk by bk minus 1 and bk minus 2, which Han Fu has already demonstrated for you in the part A. All right, I hope that was clear for all of you. Just to wrap this up, I want to thank you for you having been listening so far, and for your attention. So, of course, this is just us learning and walking you through our learning journey. So there could be some mistakes, and so please bother us if there have been any mistakes. And if you have any questions, please drop them in the comment section below. We would love to hear them. And last but not least, we want to shout out to Mr. Lin, who has been a wonderful and amazing instructor. Had it not been for his help, we could have been able to put forward this idea and bring them together in this video. So huge credits and huge gratitude for him. All right, goodbye. I think